Trigonometric identities, we have talked about some of these already. For example, tangent theta is sine theta over cosine theta. We had cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is cosine theta over sine theta. Those are the trigonometric identities we have already discussed. Okay, we should be familiar with those. Why are we dealing with these? We're going to call this the Pythagorean identity because in this picture, hopefully we remember we're dealing with a triangle, a right triangle specifically. Okay? This length right here is sine theta. This length right here is cosine theta. And in the unit circle, we have that is going to be 1. By the Pythagorean theorem, we have sine squared theta plus cosine squared theta equals 1 squared, which is just 1. And just as a note for that sine squared theta thing, if I write sine theta squared, that is vague. That could be sine theta squared, or that could be sine of theta squared. To eliminate the vagueness there, what we say is this is going to mean that one. This, in order to make it easier to write, so that we don't have to put those parentheses every time, this we're just going to write as sine squared theta. So that should explain the notation right here. So this is a very important thing. We're going to be using this a lot today. We can also say here sine squared theta is 1 minus cosine squared theta, or cosine squared theta is 1 minus sine squared theta. That's just from taking this equation and either subtracting sine squared from both sides or cosine squared from both sides. If I take the identity we just had, divide everything by sine squared, for example. If you divide that entire thing by sine squared, that's the same as dividing each part individually by sine squared. Like this. Sine squared theta over sine squared theta, it's something divided by itself, so that's 1. Cosine squared theta over sine squared theta. We know that cosine theta over sine theta equals what? This is cotangent squared theta. 1 over sine squared, similarly that ends up being cosecant squared theta. So that's another identity that we're going to end up being able to use. 1 plus cotangent squared theta is cosecant squared theta. So let's divide everything by cosine squared this time. What does that give us? That's going to give us tangent squared theta plus 1 is secant squared theta. Verify the trig identity. This is going to be like a proof. Like a proof. Verify the identity means this equation is true, but you need to make sure it's true. Which means there has to be like a brick wall between the two sides. You can't move anything from one side to the other, because to move things from one side to the other in an equation runs on the assumption the equation is true. We are not going to run on the assumption that it is true, even though we are trying to make sure that it is true. So here, on the left-hand side, the way this is going to work, using our identities, we have sine theta. We can multiply by cotangent theta, which is cosine theta over sine theta. That's one of the identities we reviewed on the first page. When you do that multiplication, the sine thetas cancel. So the left side is cosine theta, the right side is cosine theta, so we're finished. Again, we want to pretend that there is a wall between these. In this one, secant theta is 1 over cosine theta. Cotangent theta, just like it was in the last problem, is cosine theta over sine theta. In this case, the cosine thetas are going to cancel. We're left with 1 over sine theta, which is cosecant theta. Got that here, got that here, we're finished. Another verification, there is a line going down here. In this one, we had an identity earlier about 1 minus cosine squared theta, said that that was sine squared theta. So we have sine squared theta over sine theta. What does that simplify to? Just like x squared over x is x, sine squared over sine is sine. We have sine here, we have sine here. We're good. Here, we have our little wall. We can't cross the wall. Now, we want to ideally rewrite this all in terms of one trig function. This is the first problem where a little bit of thinking ahead is important. This is secant theta. Secant theta is 1 over cosine theta, right? So let's rewrite this side in terms of nothing but cosines. Because the right side we now have in terms of nothing but cosines. Let's rewrite this in terms of nothing but cosines. We have 1 minus cosine squared theta times 1 over cosine theta plus cosine theta. So this is the identity we used in the last problem. This is an identity we've known for some time. Now, we're going to distribute this through. So we get 1 over cosine theta minus cosine theta plus cosine theta, which hopefully we all realize is 1 over cosine theta. That is the same as that. We're done. Now that we're not verifying, we want to simplify. Our goal is to try and rewrite this in terms of just one single trig function. The easiest way to do this one, 1 plus cotangent squared theta, we had an identity for earlier. What was it? Cosecant squared theta. Okay, again, that is an identity we had earlier today, that 1 plus cotangent squared theta equals cosecant squared theta. So when you're doing the homework, you're probably going to want to have all those written out that you can see all of them readily, because I don't expect any of you to have them memorized today. So now what we can do is say that cosecant squared is 1 over sine squared. Cotangent squared is cosine squared over sine squared. How do you divide two fractions? You multiply by the reciprocal. So we have 1 over sine squared theta times sine squared theta over cosine squared theta. Sine squareds cancel. So we get 1 over cosine squared theta, which is secant squared theta. So when we simplify, our goal is to rewrite in terms of one trig function. We've done that. Simplify this expression. Now, there is a straightforward way of doing this, which takes more time, which would be saying secant squared is 1 over cosine squared. Tangent squared is sine squared over cosine squared. We have two fractions with a common denominator, so we can combine those. 1 minus sine squared theta over cosine squared theta. 1 minus sine squared theta is cosine squared theta, so we get cosine squared theta over cosine squared theta, which is, of course, 1. There is an easier way. If you remember the identity from earlier, secant squared theta is tangent squared theta plus 1. Secant squared theta, from earlier, we had an identity saying it's tangent squared theta plus 1. What is tangent squared theta plus 1 minus tangent squared theta? 1. Doesn't matter which way you do it. This way means that you don't have to remember this special identity here, but it takes a little bit longer. This way is much shorter, but you have to remember the special identity here.
But that's only with secant.